Most people look up at the night sky and see distance, light years, empty space, unreachable worlds scattered like distant fires. And then comes a simple question that feels almost childish at first. What if we just went faster? What if we ignored the limits and built something powerful enough to cross the universe in a blink? It sounds like progress should eventually solve it. That's what we expect. Every generation breaks some barrier. Every century bends some rule. But here's where things start to get uncomfortable. Because the closer we look at the universe, the more it feels like it is not just difficult to travel faster than light. It is forbidden in a way that has nothing to do with technology, and everything to do with reality itself, not because we lack engines, not because we lack energy, but because the universe seems to have built the rules in such a way that the idea of faster than light doesn't just fail, it collapses under its own logic. And once you start pulling on that thread, it doesn't just lead to spaceships and stars. It leads into something deeper. It leads into time itself becoming flexible, into cause and effect starting to behave like they are negotiable, into the strange realization that what we call motion might be far more limited and far more carefully structured than anything we usually imagine. So the real question is not how we might one day break the speed of light. The real question is why the universe seems so determined that we never will. And to understand that, we have to go where intuition stops working and physics begins to show its most brutal truths. The idea that nothing can travel faster than light is often misunderstood as just another scientific rule, like a speed limit on a highway that might someday be bypassed with better engineering. But in modern physics, it is not a rule in the ordinary sense. It is something deeper, something woven into how space and time themselves behave. When people first hear it, they imagine powerful engines, futuristic spacecraft, or some hidden loophole waiting to be discovered. Yet, the more carefully you look at the structure of reality, the more it becomes clear that faster than travel is not just difficult. It is incompatible with the way the universe is constructed. The first thing to understand is that the speed of light is not about light alone. Light just happens to be the fastest thing that naturally exists because it is made of massless particles called photons. The deeper truth is that this speed is really a property of space-time itself. It appears in Einstein's theory of relativity not as an arbitrary number, but as a conversion factor between space and time. Space and time are not separate arenas. They are fused into a single fabric, and the speed of light is what defines how that fabric behaves. If you try to imagine changing that speed, you are not just adjusting a number, you are attempting to rewrite the geometry of reality. Everything about cause, effect, motion, and even existence would have to change along with it. As soon as you consider accelerating an object with mass toward the speed of light, something very strange happens. At everyday speeds, adding energy to an object simply increases its velocity in a straightforward way. Push harder, it goes faster. But relativity refuses to behave so simply. The closer an object gets to the speed of light, the more its energy begins to transform into something else entirely. Instead of producing proportional increases in speed, the energy starts going into increasing the object's relativistic mass energy. From the perspective of the equations, the required energy grows without bound. It does not just become large, it becomes infinite at the speed of light. That is not a technological inconvenience, but a mathematical wall. No finite engine, no matter how advanced, can supply infinite energy. So even before talking about faster than light travel, nature places an absolute barrier at reaching light speed itself. Then comes one of the most counterintuitive consequences of this structure: time dilation. When an object moves very fast relative to an observer, time itself slows down for that object. This is not an illusion or a psychological effect. It is measured and verified. Atomic clocks on fast-moving aircraft tick more slowly compared to those on the ground. As speed increases toward the speed of light, time for the moving object slows more and more relative to the outside world. If, hypothetically, an object could approach light speed, time would nearly stop for it from an external perspective. This creates a strange asymmetry. A traveler moving close to light speed could experience only a short journey while the universe outside ages dramatically. It gives the illusion of fast travel, but it is not faster than light motion. It is time behaving differently depending on motion. The universe is not allowing shortcuts in space. It is simply stretching and compressing time itself, depending on how you move through it. However, this strange behavior also exposes why faster than light travel would break something much deeper than speed limits. It would break causality, the relationship between cause and effect. In everyday life, causes always precede effects. You strike a match, and then it ignites. You send a signal, and then it is received. But in relativity, the ordering of events depends on the observer's motion when faster-than-light travel is introduced. If information or matter could move faster than light, there would be reference frames in which the effect happens before the cause. A signal could be received before it is sent. In extreme theoretical cases, this leads to paradoxes where a message could be sent into the past and prevent itself from being sent at all. The structure of logical consistency begins to collapse. Physics is not just concerned with what is possible in isolation, but with what remains self-consistent across all observers. Faster-than-light travel breaks that consistency, and so the theory does not merely discourage it. It forbids it through the architecture of space-time itself. Another important point is that motion through space is not independent of space itself. In relativity, space is not a passive stage where things move. It is an active geometric structure that responds to energy and momentum. This means that trying to exceed the speed of light is not like pushing an object harder through empty space. It is more like trying to deform the rules of geometry while still expecting consistent motion to exist. Space and time are interconnected in such a way that motion affects how time flows and how distances are measured. At high speeds, lengths contract in the direction of motion, time dilates, and simultaneity becomes relative. All of these effects work together to ensure that no object carrying information or mass can outrun the structure that defines the speed limit in the first place. It is not that space resists motion like a physical fluid. It is that motion itself is defined within constraints that already encode that limit. This leads to the most speculative part of the discussion, where people often turn to ideas like wormholes or warp drives as possible escapes from these restrictions. In theory, a wormhole would be a shortcut connecting two distant points in space-time, allowing travel without moving through the intervening space. A warp drive would instead contract space in front of a ship and expand it behind, allowing the ship to ride a wave of space-time distortion. These ideas are mathematically intriguing and arise naturally from the equations of general relativity. However, they come with enormous physical problems. Both concepts require forms of matter or energy that have never been observed in the necessary quantities, particularly negative energy density or exotic matter with properties that violate known energy conditions. Even if small effects related to negative energy exist in quantum physics, scaling them to macroscopic structures is beyond anything currently known. More importantly, even if such structures could exist, they often reintroduce causality problems, effectively allowing the same paradoxes that faster-than-light travel would create through ordinary space. The deeper lesson in all of this is that the speed of light is not just a limit placed on objects, it is a fundamental feature of how reality is stitched together. It defines how information moves, how cause and effect are ordered, and how space and time are measured. When you examine it carefully, you begin to see that the universe is not simply preventing us from going faster. It is maintaining a consistent, logical structure where every observer, no matter how they move, agrees on the basic ordering of events in a way that avoids contradiction. If faster-than-light travel were allowed, that consistency would unravel, not locally, but across the entire structure of physical law. Even quantum mechanics, which often appears to challenge intuition at microscopic scales, respects this boundary. While quantum entanglement creates correlations between great distant particles that seem instantaneous, it does not allow information to be transmitted faster than light. Nature seems to preserve the same boundary in every layer we examine, from the smallest particles to the largest cosmic structures. This consistency suggests that the speed of light is not an accidentally feature, but a deeply embedded constraint shared across all known physical laws. As the exploration of these ideas continues, one begins to notice that what initially seems like a limitation is actually part of a much more intricate balance. The universe allows enormous flexibility in how time and space are experienced, depending on motion and gravity, yet it preserves a strict boundary that prevents logical contradictions. That boundary is not enforced by force but by geometry itself, as if the structure of space-time is self-regulating in a way that forbids certain kinds of inconsistencies from ever forming. And thinking about how this structure might behave under extreme conditions leads into even deeper questions about whether space-time is fundamental or emergent, and whether the speed of light is a derived property of something even more basic that underlies everything we observe. In the end, the idea of faster-than-light travel doesn't fail because humanity lacks imagination or engineering power. It fails because the universe is not built like a road waiting for better vehicles. It is built like a tightly woven structure where space, time, energy, and information are locked together in a way that refuses shortcuts. What we discover, again and again, is that light is not just something that moves through the universe, it is part of the universe's deepest rulebook. The closer we try to push against that boundary, the more nature responds not with resistance in the ordinary sense, but with consequences that reshape time, stretch energy requirements beyond infinity, and threaten the very consistency of cause and effect. So the real lesson is not disappointment, it is clarity. The universe is not holding us back out of limitation. It is maintaining order at the most fundamental level. And in that order, every event has its place, every cause has its effect, and every motion has its boundary written into the fabric of space-time itself. We may never cross the speed of light, but in understanding why, we come closer to understanding something far more profound, not just how the universe moves, but why it cannot allow itself to fall into contradiction. And that understanding is, in its own way, its own kind of journey. Good luck to you on your journey of curiosity and discovery. May you always question deeply, think clearly, and never stop exploring the mysteries that shape reality itself. Thank you.